Hi all, I'm Ritu.
Hey everyone, I'm Hamakshi.
Hi guys, I'm Sejal.
Hi everyone, I'm Himanshu.
Hi everyone, I'm Ritu Malav and I'll be starting off with our presentation on behalf of my team, that is Himakshi Pandey, Himanshu Pant and Sejal Kedikar. So this is our project for SER502, which is named as Sinlang. So this will be our overview for this presentation. I'll be starting with introduction. So our project is called Sinlang. It's a lightweight expressive programming language created as a part of SER 502 course. So the core idea behind this Sinlang is to design a language that feels similar like Python, but also allows a room for experimentation. So it combines readable syntax with custom grammar that encourages both creativity and clarity. So this Sinlang supports essential programming construct like variable declaration, arithmetic operation, conditionals, loops, functions. All these are implemented through a grammar we built using Antler 4. So the language is interpreted using Python, which allows us to focus on language behavior while keeping the runtime manageable. So with GitHub for version control, we collaborated closely to develop and refine our Sinlang into a working language prototype. So now that you have a high level overview of what a Sinlang is exactly, now I'll be handing over to Himakshi. She'll be explaining you the life cycle and the features of Sinlang. Over to you, Himakshi. Thank you.
Thank you, Ritu. So let me walk you through the design pipeline of a language lifecycle. You start with a source code written by the user in .syn files, which describe the logic using the language constructs. The source code goes into lexical analyzer powered by Antler. It breaks down the code into meaningful pieces like keywords, identifier, and symbol, forming a token stream. The parser then applies a grammar to these tokens and produces a parse tree reflecting the syntactic structure of the program. Once the structure is built, we run a semantic analysis. The result is an intermediate representation, typically a decorated AST, which is abstract tree syntax, which is then handed to an interpreter. The interpreter evaluates expression, follows control flow, and invokes function as needed. Finally, the program produces the output. Next, over to core language features. The language is strongly tied with explicit support for int, bool, string. It provides full suite of expression types like arithmetic, relational, logical, and ternary operation. Variables can be declared with types, reassigned, and even updated using increment and decrement operators. On control flow side, we support all essentials like if-else, while traditional C style and Python style foreign range loops. The language supports functional declaration with parameters and control structures inside. Next. So these are the data types which we suppose all three primitives, which is int, bool, and string. Assignment can be expression, and we also support post, increment, and decrement operator. And we have arithmetic operators, which is basically addition, subtraction, etc. And we have relational operators, which is less than, greater than, and equality operators, equal to, not equal to check logical state or matching values. And we also have logical operators, which is handled through and, or, and not. These are combined to build compound conditions. And then we have ternary operator, which is nessus ternary, which allows chaining decision in one line. Next, a control flow. If else block allows conditional branching, while loop is used for conditional control repetition. For loops which with initializer condition and update, and for each loop gives more Python way to iterate over numeric interval. Next, for function, which are defined using function name syntax. They support parameters, local variables, and all form of control flow. And in this example, we have defined a main function that calls check value, which uses deeply nested if-else block. Over to you, Sejal.
Yeah. So let's get started with the Sirlang grammar. So Sirlang supports essential programming constructs that we often see in a mainstream languages such as functions, variable declarations, control flows like if or else, while loop, for loops, various types of expressions, and the ability to print and call functions. So the entry point of this grammar is defined by the rule program block EOF, with meaning that the program consists of a block followed by the end of file. Next slide. So now moving towards the function and the block structure. In Simlang, a block is a sequence of multiple constructs like function declaration, variable declaration, and function calls. You can think of a block like a body of a program or a grammar. A function declaration starts with a keyword function, followed by the name, parameters, and a block of statements wrapped in curly braces. So this gives Simlang a Python meets C feels. Moving towards the next slide. So this slide uh, covers the variable declaration and the control structures. Variable can be declared with a type or just reassigned directly. For instance, both int is equal to a, int a is equal to 5, and a is equal to 5 are valid. Statement includes variable assignments, print commands, if and else conditions, loops, increments. So Simlan supports a C style and a Python style loops. This supports this gives programmer flexibility on how to write. So next is the expressions, and the expressions are passed in layer manner from top level hierarchy to atomic units. Ternary of expressions like sits at the top. Then comes the logical operations, and the third is the comparisons, and finally the arithmetic operators. So the most basic building block are primary expressions, which contains of literals, variables, function calls. Moving towards the next one. So the in Simlang, a function call is as simple as a function name followed by argument in parentheses. Increment operations are also supported and with both post style like x plus plus or compound statements like x is equal to x plus is equal to 2. The Lexer rules defines how token-like types, literals, operators are recognized. White spaces and comments are ignored during to keep the things clean. So this is all about the grammar of the Simlang. So moving towards on how the a simple walkthrough, Himanshu will explain that.
Thank you, Sejal. Hi, everyone. I'm Himanshu, and I'll be walking you through the sample code for a custom language, Sinlang. The idea behind these examples is to demonstrate how Sinlang supports programming basics like variable declaration, loops, booleans, and ternary operation. Each file that I'll show you will highlight one or more of these features. So next slide, please. So the run, before jumping to the code, let's first briefly discuss the run workflow. We have the code in Sinlang in a folder called data folder, and we have the parser, the lexer, and eval visitor function which we have written, which is a Python script. All of this is being used by a script called run Sinlang, which combines all of this, calls the data file, creates the parse tree, and then uses eval visitor to find to get the final output. And the output is printed directly, and execution, as I said, is handled via eval visitor. Now I'll quickly share my screen to show you some of the programs by running them. So let me share my screen quickly. Let me know when it is visible.
Yes, it is.
Okay, so let us test the bool test first. So this is the bool test file that we have. Top here you can see we are declaring some of the bool variables. We have bool t is true, bool f is false, and then we have a bunch of operations here. Bool a is an and of t and f, so it should come out as false. Bool b is an or, which is for t and f, so it should come out as true. Then c is a not of f, d is an equality, and e is an inequality test. So how do we run that? We first have to get inside the runtime folder, and within runtime we have eval visitor and runs and lang. So what we do is we type Python and we do runs and lang. So what runs and lang does it goes to the data folder and scans through all the files and prints the name of those files. So as you can see, it has printed all the files which are currently present in the data folder. We have all these files present. So what the user is supposed to do is to type in the name of the data file which they want to test. So right now we're testing for bool. So I'll just quickly type in bool test. Mind you, we're not supposed to type in .sy file extension. So I just typed bool test. When I press enter, it'll show me the output, which happens to be correct because print a was and it is coming out to be false. Everything else is True. So let us quickly also do one more test. Let us do a for test for this. So this is a simple for test, which is like a classical C for test. So this is a classical C for. Here you can see we are declaring we have a condition, then we have an increment increment within this. So what we can do is we can again run lang, and we can now type in for test. And once we do that, the output is coming out to 55. Now, if you look at this function, it is starting from 1. It is incrementing that it's going all the way till it is less than equals to 10. So if we, and it is adding to the sum, which is 0 initially. So it should come out as 55, which it is. So this demonstrates that the function, that all the test files are being correctly passed and evaluated as it is supposed to be. Now back to Ritu for future scope. Thank you.
Thanks, Himanshu. So discussing about the future scope of our SynLang. So we plan to implement semantic analysis, adding type checking, scope validation, and stronger error handling. So this future features will include unit testing support, complex data types like list, dictionaries, and we also try to implement like a lightweight ID integration to make SynLang even more interactive. So that's all about our SynLang. Thank you.